Alright, so what's the topic today?
Today we've got another hour of Fedora and Python with the stress put on Fedora Python. So there's an issue. There's an issue of a segmentation fault happening when a Python process is running while Python is being updated.
Right.
Which is a very weird use case, but apparently a valid one, and we want to support that.
Right, so you're updating Python 3.14, right?
3.14, yes.
From .2 to .3?
Exactly.
Right.
Just 1 second, please. I will pour some water and be back in a minute. I'm back.
Okay, and you are getting a segmentation fault when you import pickle or when you do some async IO stuff.
Yes.
Like that. Do you have the backtrace from GDB?
I do, and I wonder what would be the best way to share it with you.
Well, let's maybe put it in HackMD.
All right.
Oh, I don't go to HackMD as often as I thought.
So let me just run it. I will create a note and I will share it with you. So So you should see the link in the chat, and it should allow you to read and write in that note.
Right. So, there's the backtrace. We have syntax highlighting. Yes. Well, almost. Good enough. All right. So, there's the C backtrace. It looks like it's. Oh, this is the async IO one.
Oh yes, this is the async IO one.
Right.
I probably could produce another one with pickle in like 3 minutes.
Yeah. So the pickle one. The pickle one was probably clear, but let's look at this one. So there's the PyObject_get method at object.c 1590, which calls PyObject_getAttr, and okay, it calls PyObject_getAttr if the name is not exactly Unicode. And I think the problem is in. Oh, it isn't getAttr. Okay. So PyObject_getAttr at object.c 1220. So this does PyUnicode check on the name,
Mm-hmm.
And what does PyUnicode check? It calls PyType has feature, which gets the type, that's the type of the object, and it gets the flags from that.
Mm-hmm.
Problem is, the type is not a valid pointer, so this read of something in the type blows up. So to see what the problem is, we need to look at this call, I think, object vector call method on in call.c. Oh no, that still gets the name somewhere. Future init. That'll be the one. So future init is probably in some async.io module. Here it is. And it calls PyObject call method no args. That would be this one. So the problem is here.
Mm-hmm.
So this call method no args takes an object and the name of a method as a Python string and calls that method. The name is this PyID thing,
Mm-hmm.
which I think is defined in PyCore Unicode objects generated.h. No, so this is not it. PyTime run. Here it is. Probably. Yeah. So there's a macro called like init id, and it's I guess it's not defined exactly here, but there's a giant list of all the strings used in the CPython source, in the C code, including that. Which one was it? I forget which one. But this is just an array of Python string objects. And they all get initialized when Python starts up, and when something wants to get at the object, like here, it just gets the address of the string that's already there.
Mm-hmm.
The problem is this giant array lives in libpython. So when you get this pointer, that gets the pointer from like the runtime structure, that there's a singleton, and this means just reaching at a specified offset in the memory for this string get debug, right?
Mm-hmm.
So if there was a change in the structure somewhere before this string, you'll get a different object, and you're out of luck. So with that, we can maybe look at the ABI diff.
Yep.
Once again.
Let me share. Probably a nicely formatted, like better formatted one will be here. It's with indentation.
Oh, nice. Can we... make this bigger? Okay, so in some function that takes a pointer to PyInterpreter state, this PyInterpreter's data type has changed. It's the struct is. The type size hasn't changed, but two data member changes. Blah blah blah. And I guess here are the problems. So these are all the things whose offset changed. And the offsets changed from some number to some other number, and that includes I guess the PyStatic objects is the one that includes the strings. So this is the one that everything pokes at when it needs to get a string. So the problem here is ceval runtime state changed because there were 3 data member insertions: previous eval frame, trampoline ref count, and code watcher ID. Whatever that is, I have no idea. But if I'm in the CPython source, in the 314 branch, I can do git log, show me the diff, and show me the commits that add or remove this string. That's the -S. And yeah, so this is fix undefined something, probably
After free?
Oh, use after free, right. Improve trampoline during finalization. So this changed the ABI. So this giant XML file got changed, which is usually not very helpful because it has all the changes and you need to run the tool to get something interesting out of it. Wow, that's a lot of changes. So instead of -p, I'll do stat. Okay, I can just look at this commit. So what changed? Here it is. So previous eval frame and trampoline ref count and code watcher ID were added in this commit.
And that's a commit that wasn't there in 3.14.2, but was added in 14.3.
Right. So fix use after 3 and improve trampoline when toggling profiling while threads are running or during interpreter finalization with daemon threads active. Fix uses reference counting to ensure trampolines are not freed while any code object will still reference them. Huh. You probably want this fixed in Fedora, right?
It sounds like something that we would like, yeah.
Okay, so we cannot just get rid of it. Let's see. Probably can't get rid of that very easily. So, what can we do? do we want to add a check to every built-in module that the runtime version of Python is the expected one?
How would that behave? If the runtime version was not the expected one?
It would raise an error.
Okay, so in that corner case that we're talking about, it would basically kind of like invalidated the Python use unless you restart
Right.
the interpreter correctly with everything loaded.
Yes.
As it should be. If that information is visible to the end user and they know what happened, or like they see that there was a legit error instead of segmentation fault, I think that's a good state, because
well, I guess that's the most we can do.
like we don't aim to fix things for them. It's just a state they should recover from by acting rather than expecting that it somehow automagically fix itself.
Yeah.
So yeah, do we have a mechanism like that?
So we would need to add it. So the mechanism exists in Python 3.15. So long term, the change to make would be to add it to all the built-in modules. But,
is this something that should happen on the CPython level, like upstream level, or is it something?
So that one can. So for 3.15 we can do it upstream. There's also something we can do for 3.14, but that would be a new feature, so it couldn't get into 3.14. So there's not much reason to put it in.
Mm-hmm.
So that would need to be downstream. It would only change the well, the module is using the internal API, which is CPython itself and probably some ill-advised projects like Python. So let's look at the long-term one first. So if you look in the main branch in modules, I think it's objects. Module object. There's this module slot called PyMod ABI. What is that? So you declare an ABI info struct, which gets filled with information about the expected ABI. You put in this slot, and it automatically gets checked.
Mm-hmm.
Right? It's not really used too much, but I think it's used in one module as a test. And if you want to add it to all the other ones, I'd happily review that pull request. Let's go to that's the internal API. Oh, here, PyInternal API slot. So it's used in the datetime module. I think that was the one that caused trouble last time, right?
Yes.
So there's module slots for the datetime module, and it has this PyInternal API slot. If you want to send a pull request that adds this to all the PyModule dev slot arrays you can find, except the testing ones that don't use the core. Well, only the ones that use PyBuild core or something, right? So if it, then, yeah.
All right.
I would review that. Alternately, you can use the official API for this. So this is not for everything that's not a core, that doesn't use the core or the private API. So basically, whenever that macro is not defined. So that would be the long-term thing. For 3.14, we can do something similar. So what happens here is there's a PyAPI info check, and where is that defined? In mode support. So API info check basically raises an error if something is wrong. The giant function that formats the error, but basically says something is wrong. And we can do that for all the built-in modules. So let's see, let's go for the one that's causing trouble. Which one was that? Pickle, right?
Pickle. It's underscore pickle.
Pickle.c. So how is this defined? This has slots. And it calls PyModuleDef init. So there are two ways you can create modules. One is with PyModuleDef init. The other one, the older one, is PyModuleCreate. I hope there aren't any modules using that. So PyModuleCreate is used in test things, in tkinter, and in trace malloc, and in readline. Okay, so these three would be a bit different. All the other uses are documentation, headers, metadata, implementation of PyModuleCreate, and more implementation of imports. I guess there's also instrumentation in the sys module, but I don't know if instrumentation is probably not an extension module, and sys is loaded at the start, so you won't get any problems with that. So for these three, you'll need to do something else. For everything else, we can use we can monkey patch this PyModuleDef init. How do we do that? So PyModuleDef init is defined in moduleObject.c. There's a big heuristic check we can ignore. And then there's some settings on the object, and then it returns the object, right?
Mm-hmm.
So what we do is we change the header file. There's moduleObject.h that defines this function.
Mm-hmm.
And we say that instead of this, whenever something calls pymoduledefInit in the source, it will actually call some other function. Okay? So if we do if def and I need to switch to 314. So if def py build core underscore. So we only do this for the built-in modules that use the internal API. I don't think this is used anywhere else. So if we're building a core module, then we define pymoduledefInit as pymoduledefInit with check. Right?
Mm-hmm.
And before that, we define a static inline function called pymoduledefInit with check. Do you know what static inline means?
It will not be exposed anywhere.
Yes, it will not be exposed. It's basically like a macro. It gets compiled into every call, right? So there won't be any linking going on. There won't be a symbol. You can't call this from like C types or Rust or something like that. It's basically like a macro.
Mm-hmm.
So it needs to have the same signature. So return type will be the same, and the signature will be the same. And the basic implementation will return pymoduledefInit with its argument. Now this is before we redefine pymoduledefInit. Right? So after this define, all references to pymoduledefInit textually will be replaced with this. Right?
Mm-hmm.
So instead of calling this function, the code will call this function, which will call the original pymoduledefInit. This one isn't replaced. Right?
Oh, okay.
And how do we ensure that we can define the function at all? Where is it defined? I think it's should be somewhere here. So there's a problem here, because now if we have this defined, I copy it here for reference, that means this also gets replaced with that, and we're not defining the pymoduledefInit function anymore.
Mm-hmm.
So what we do is we undefine this. Right? So now we're actually defining this function with this name, and it'll be callable by the extension modules, including this one. Right? We also have the header definition for it. Does that make sense? This is quite convoluted.
Yes, it is. It is. I'd like to say it does make sense, but it really kind of doesn't, because you redefine, like you said that it's textually redefined every time PyModule def init is changed for PyModule def init with check.
Yes.
And just before they
from this moment on.
Yeah. And how do we know that the implementation where in that place where you just undefined it is before that? Or like, no, it's not before that.
No, it's not before. This one is after. So after this, PyModule def init is PyModule def init again, right? So for the remainder of this module, which doesn't use, or which uses PyModule def init, the original function. And here again, and that's it.
So for the rest of this module, it's the original function.
Yes.
But when we want to use it,
when we use it from Pickle,
in Pickle, it will be the monkey patched, or like
yes,
replaced.
This will be replaced with the static inline function, which will in turn call PyModule def init. So we can do something like print patched PyModule def init right. Let's see if that works. Oh, static inline by object. Right. Call Python. Import Pickle. And it goes through our patched PyModule def init. Okay.
Okay.
And what we do here is we compare two values that should be the same, but one of them needs to be compiled in, and the other one needs to be retrieved from the libpython dynamically.
Yeah.
And this was added. This was added not that long ago. There's PyVersion, which is the Python runtime version number. This is a variable, and there's also there's its PyVersion hex, and this is a macro. So that's the compile time constant. So if PyVersion hex is not equal to PyVersion, then we have a problem. And we can do py error format, and we'll do a py exception, and this should probably be a system error. Something is wrong at the C level. And we go, well, we have the module name here. Right, so let's make it, let's make it this, and then the def name for this one. That's compiled with the PyVersion hex. Let's get rid of that to int for good measure. And the PyVersion, what data type is that? Const unsigned long. So this should be Alex, I guess. Hopefully. I think I'll get it.
I think the comparison is wrong on the line 44.
PyVersion is undeclared. So yeah, I guess that's a problem with header order. So PyVersion is declared in pylifecycle.h, and if I look at python.h, PyLifecycle is quite at the bottom, and module object is before it, right?
Mm-hmm.
So what do we do? Oh, we declare it here again. This is a hotfix, right? We don't need to do anything special. Oh, and we also don't have PyModule dev defined yet. It's defined a bit below that, so let's just move this whole thing here. And that should be it.
So does a module know that it was compiled with a different, the given Python version?
Yes, the PyVersion hex is the version the current code is being compiled with.
And it's already there, like Python 3.14.2.
Yes.
The modules know, kind of like have the information.
Yes. So that's defined. So that's textually replaced with with the number, basically. And PyVersion is a variable that's defined in libpython, and it's read from there.
Yes.
Okay.
There's another question brewing, but no words yet.
So let's look at the PyModule create ones again. So lots of test ones, which is fine. If those segfault, the test failed, right? So we have tkinter, tracemalloc, and readline. So let's look at those. tkinter, does this use any internal API? It does. So we probably need to do the same check in this pyinit function, like manually, right? So by redefining PyModule def init, we now don't need to go into every module and add the check there. But here it's just 3 of them, so it's probably better to just add a check. So we can do something like
this is going to invalidate the possibility to import a module compiled for a newer Python when like an older, you compile it with an older Python when a newer Python runs it. Just like flat out, it will just make it available for modules to get imported.
True.
Always. Regardless.
For PyBuild core.
Mm-hmm. Regardless whether they would be like importable, no changes there, or they wouldn't because of the issues like we just experienced with Pico or Asenka.
Right.
Uh-huh.
There's not really a different way to know.
Okay, so the solution to this corner case of Fedora is basically making it always fail for the user with an information it doesn't work. Don't do it.
Right.
Okay. Yes. I understand it correctly.
Yeah, we should do something about that as well. So here we can do if this call raised an error, we should return null.
Mm-hmm.
Yeah, the return null was missing there before. And now this is the check we can do in tkinter. And trace malloc. And in readline. Right?
Mm-hmm.
Okay. So that should be what you need if everybody was well behaved. Oh, using the name in the error message. Right. A bit different then. This needs a string. And it needs to be called with the module name every time. Now there's one more problem which I just realized thanks to your question. There are some extension modules that are not well behaved, like Cython.
Mm-hmm.
Cython defines PyBuild core and pokes at the internal API, which is a problem if it uses any of the PyID APIs, but I guess it shouldn't use that directly, hopefully, nowadays. So what you might do is define a different macro. Like this. can do, if this is defined and PyBuild core is also defined. Right? So this will only be done for the core modules that have this, and this is something you can set just for the RPM build.
How would I do that? How would I set it only for RPM? It's like would that be a patch somewhere in
Yeah, you need to set a compiler option. Right, on the URL here for the bug. You need to set a compiler option, so that would be in C flags. Do I have Python 3.14 spec? So you have C flags and you have C flags noticed. So these C flags noticed, those are the ones that don't then get compiled into what the extension modules use, right? So here you would do -d, which means define, and whatever
hack something.
Whatever the macro name was.
All right.
I'll try that as a workaround. Hopefully it'll be fine.
I'm a bit worried about what you said about CPython, but with this additional macro, it shouldn't affect CPython.
Right, it should only affect what you built here.
And with that, anytime somebody had a Python process running while updating Python.version, trying to import any of the internal modules would result in this is mismatched version. I can't do anything about it.
Right. And I guess, oh, this is a weird operator. Well, we're on the learning C thing. So this is a preprocessor operator, right? So the preprocessor that handles these preprocessor commands, like if, has a special case for the word defined, where you put in the name of a macro that could be defined, or maybe it's not. And with that, you, well, instead of if-def, you can do more complex expressions here.
So it's a way to go if you want some like Boolean.
Yeah.
Want to implement some logic, additional logic.
You can see it's used all over. Is this the right? Yes. So here's the patch.
I'm going to send it to Fedora Python repository to our copy and get more eyes on it.
Yeah, see if that works for you. And for 3.15, yes, we.
Okay, so for 3.15, the mechanism is in place. Not such a complex mechanism. The complex mechanism is in place, but it's not yet added to the modules. And the change, as I understood correctly, is just defining this ABI check in the module slots.
Yes. So if you do the macro that was added there, I don't know where. Oh, already lost that. Yeah, I'm not a main right. So you can either do this. Where is it? Is it core somewhere? PyCore mod support. Ah, here it is. So if you use this PyInternal ABI slot, that's only available for the modules that use the internal ABI. But it's simpler to use. For all modules, you can use it in the defined way. Just one extra line. You need to define a variable and then reference it.
Mm-hmm.
So if you don't want to care about which module is which, you can just use this every time, I think.
Oh, all right.
Right.
By any module, you mean those, for example, one of those three that are not using the.
Well, the ones that are not using PyModule def, you can't really add it to those.
Mm-hmm.
To those, you can add the check manually. And by the check, I mean a different check.
Okay.
There's PyABI info check. So you do this PyABI info var, and then you call PyABI info check with that variable and module name. Because there's no slots for those modules.
Mm-hmm. All right. make an attempt.
Right, good luck.
Thank you.
Hopefully it'll work. Hopefully we didn't forget something important.
I'm super curious how the tests will behave and furthermore. So with the patch that we just devised, that you just devised, if it should be really enough to just patch the .3 Python. I don't have to patch retrospectively .2 and then .3 in order to make sure that everything works.
Yes, because, well, unless you want to guard downgrades, right? Because the older Python, like libpython, is already running and loaded in memory. So this only happens when you load an extension module, which is where we added the check.
Yes.
If you want to do this for downgrades as well, probably can't.
I don't think Fedora officially supports a concept of downgrade. Like it does, DNF allows you to do that, but I don't think it's, or is it? Why do I have an idea in my head that it's not supported?
Well, that's coming in 3.15, so.
Okay. Soon enough.
And Python doesn't officially support, upgrading it while it's running. But hopefully this.
Well, with this mechanism, it officially stops supporting it, basically. At least for the internals, at least.
Right.
It will just like.
Well, with this mechanism, it'll raise an error for it. At least for the modules that care.
Yeah. Which is nicer than segmentation fault, for sure.
Yeah.
I'm really surprised it worked for quite a long time for some people, apparently.
Yeah, that's probably because Python didn't change the runtime struct so much.
And that has started to happen because of the free threading things and the internal changes.
Free threading things. So last time it was because somebody added a new static string. And if that's what happened, that would have been quite easy to roll back, right? Because in the code, instead of getting the static string, you create a new string, which is a bit slower but worth it. There's this problem with what was it again? Profiling trampoline. Yeah, that's quite new. And it happens to be in the runtime struct before the string, so pushes all of them around. Well.
Cool. That's a very interesting rabbit hole that you come from a segmentation fault in pickling, coming to the 192 bits moved of one giant struct with compiled strings.
Yeah, well, from the pickle backtrace, it was quite obvious, I would say.
Okay, I'm going to find that one just to see. to see it again and to take a look at it. Like, what was
It
so
was quite obvious if you've seen it before, and we've seen it before with the daytime one. That was not easy to debug, but
Mhm.
I somehow remembered that that's a bug that can happen. Something that might have contributed to me remembering it, as I added this mechanism to prevent it in the next version.
All right. Okay, I'm full of ideas. I will try to process it tomorrow and start moving things for our Fedora Python.
All right.
And see you next week.